Hey folks, in this video I'm going to run you through a sample multiple regression project complete from identifying and recoding all your variables through running a visualization and then through running and cleaning the visualization and then running bivariate and then multiple regressions and then interpreting bivariate and multiple regressions. So hopefully this is a very quick look at everything that I'm hoping you'll be able to do this semester in your papers. So you'll see that it's really not, it's tedious more than time consuming, I think is the problem. All right, so to start out, I'm going to choose a dependent variable that you all are able to choose, or unable to choose rather. I'm going to use the feeling thermometer for John Roberts, Chief Justice John Roberts. Okay, so with that, there are lots of things I might want to include. I might want to include party identification. So I've already found party ID, and a bunch of you are already doing this, right? Party ID is right here. It's V161158X. Okay, and it goes from strong Democrat to strong Republican. That one, you don't need to recode. It just is increasing Republicanism. As long as you can remember that, you're golden. You don't need to recode it. Okay, so I've renamed it party ID here. Now, if you're not including party ID, you need to. Every single one of you should be doing it. As we talk about in the multiple regression videos, if you don't include important controls like party ID, your model will almost definitely suffer from omitted variable bias. So make sure you include standard controls like party ID. That people of color variable you've already created would be a really important one for most of you. You could include age, you could include household income, education. Those are the kinds of things you might want to include in all of your models. I'm not going to include them all here just for illustration purposes. All right, but those are the kinds of things you want to be aware of when you're doing your data. Okay. But let's think quickly about some of the other things that might impact how you view a key Supreme Court justice like John Roberts. For instance, abortion. Okay. Abortion, the way that this variable is coded, it's V161232. All right, the way it's coded here, it looks kind of ordinal, but it's not because you have this 5, which is other. So we can't use this in a regression because what does an increase of 1 unit mean from 4 to 5? It doesn't mean an increase in anything. All right, so instead, what we should do is create a simpler version of this variable, a dummy variable, where the 4s here, basically we want a variable that says, do they think that abortion is a matter of choice? Yes or no? If yes, 1. If no, 0. So 3, 2, and 1 all say there should be restrictions on it. 1 obviously is the extreme version where there are lots of restrictions, all right? But this allows us to account for that other. Okay, so 4 will become 1. Missings we'll treat as missing. All the other things will become 0. Okay, so we can recode that very quickly. We go to transform, recode into different. We have the abortion one there. I'm going to label this abortion dummy. And it's just going to be, is R pro-choice? So is the respondent pro-choice? And we'll go to old and new values. That 4 we want to become a 1. We want those missings to be treated as missing, and then all other values. So 1, 2, 3, and 5 become 0. Continue. Okay. Okay, and then remember when we create new variables, they go there at the bottom. And then we're just going to relabel this so that 0 look at that. There we go. Okay. So then, just to double check, this is always a good thing to do when you recode a new variable. It's always a good thing to go back and check to see if this recoded properly. Okay, so there we can see that all of the people who said that abortion is a matter of personal choice are a 1 here. All the people who said 1, 2, 3, or 5 are 0s here. Okay, so that's just a good way to double check it. So that's the abortion one. All right, so with this abortion one, we could go ahead and do, for instance, a bar graph. Just a very simplistic bar graph where we take that abortion dummy, that's our category axis, and we take our John Roberts dummy, or John Roberts feeling thermometer here. And there we go. Okay. So what do I mean by cleaning up these things? We see that generally thinking people who are less pro-choice have higher favorable ratings of them. So what did I mean when I said you need to clean these things up? Well, a few things. Number one, we need to get rid of that. Okay. So we get rid of that. Number two, this background, get rid of that. These colors are atrocious. You don't need different colors for the bars. That's kind of silly. Okay, instead, we'll go with a gray bar. And then for this, we'll do that. And here we'll say no, yes. Okay. And then there we go. We've got our clean, fancy looking thing. Okay. So other variables you might want to include in this. There is a question about gun access. Oops, sorry. Right. So there's this question that asks people, to what extent is this an important thing to you, having access to a gun? All right. And so we'll see there are people who care about this gun rights issue. Okay. So the way that it's coded right now, it's ordinal. However, as I've said to a lot of you, you generally want higher values to indicate more importance, more favorable, more approval, more whatever, right? You want those higher values to mean something common sense. Because right now, if this shows up as a negative in your coefficients, then what that's going to mean is that higher values here mean less importance. So less important, less supportive of Roberts. Okay, that doesn't make a ton of sense the way it's coded right now. So we want to reverse this. We want the ones to be fives, the twos to be fours, etc. There's two ways you can do this. Now I'm going to illustrate one way here and then another way with the next one. This one, I'm going to show you sort of the tougher way, the more tedious way. So we're going to treat it just like the same thing that we did before. All right, recode into different. And we have that gun access variable. Actually, we got to reset everything here. We'll go down to gun access. I'm going to name this gun access reversed. All right. All right, so we said 5 will become 1. 4 will become 2. 3 is in the middle. It's going to stay 3. 2 is going to become 4. 1 is going to become 5. Okay. Now, we got to deal with those missings. So if you recall, we see here that the negative 99 to negative 1 are missing. Those are what are known as user-defined missing. So when you see system or user missing, that's the user missing. Okay, they have a value, and the researchers told SPSS negative 99 to negative 1, those are missing. System missing is they're just blank, they're empty. Okay, so we're going to make them into system missing. Then we're going to click OK. All right, we're going to remember what the values up here said. Not important, not to, somewhat, very, extremely. We're going to go down to this new variable, get rid of the decimals. 1 becomes not at all important. 2 becomes not very important. 3 becomes somewhat important. 4 becomes very important. Sorry. 4, very important. And then 5, extremely important. Okay. And then, of course, you would go back. I know I did it right because I've done it already 3 times. So we can go back here. We can put them here, and it should be a nice diagonal. Whoop, there we go. Okay, looks great. All right, so that's the sort of tedious way of doing that. But there is another one. All right, so let's go down to the variable that I've renamed interest. So it's the respondent's interest in politics, not the interest in campaigns, just the overall interest in politics. Right, there's another question that asks about how much do they follow the campaigns. That's probably less important for dealing with John Roberts. Now, this one also is coded in a weird way that we want to reverse. This time it's 1 to 4. Now, we could go back and say 4 becomes 1, 3 becomes 2, et cetera, okay? Instead, I'm going to show you another way of doing this. Now, there are 4 values, okay? So, on that interest, we'll click it over. We're going to name this one interest rev. We're going to label it literally the same as the other one. Now, there are 4 values here. So what happens if you do that? Well, if your current value is a 4 and you subtract that from 5, it becomes a 1. If your current value is a 1, you subtract it from 5, it becomes a 4. What you're doing here is you are reversing the scale, the coding scheme. Okay, so in this case, because there are 4 values, you subtract it from 5. If there were 5 values, you'd subtract it from 6. Okay, so it's kind of a quick and dirty way to do this, all right, where you're literally just reversing the scale. Okay, then as before, we're going to need to copy these over just in reverse order. So not at all, not very, somewhat very. Not at all, not very, somewhat very. So we scroll down, get rid of our decimals. Create our new labels. Somewhat. And we go to 4. Okay, and then again, you would go back and do that cross tab to check them against one another. But again, it's fine. Now, importantly with this one, if they're treated as missing in the computation, they're going to be treated as missing here as well. Okay, so we can take a look at the descriptives, and you'll just see that we have 11 missing, just as we would have if we had done frequencies for the original one. Okay, so that's those. Another one you might be interested in is how they feel about Obamacare. I've relabeled this one Obamacare, but again, it's one of those weird ones that's not ordinal, right? If it's ordinal, then the 3 needs to be between favor and oppose. We're going to recode it so that 1 becomes 3 because higher level should indicate favorability. The 2 becomes a 1 and the 3 becomes a 2. Okay, so we're going to recode into different. Reset. So with this old one, 1 is going to become a 3. That was favor. Okay. 2 was oppose. That's going to become a 1. 3 was neither. We want that in between. We want that to be a 2. We got to account for the missings. Yep. Thank you. SPSS likes to yell at me. So I'll click continue, and then I'll click OK. All right. And then, as again we did before, we got to go in and deal with those values and get rid of this. So this one means oppose. 2 means neither favor nor oppose. 3 means favor. Okay, so there we go. And then we're going to do a few other things here. We have the party ID. We're going to use that people of color variable that we've already used before. There's one other variable that I want to code, and that's education. Okay, so we'll find their highest level of education, which is right here. So if you look at education, it seems kind of ordinal, but just like in the one that we dealt with before, with the abortion one, there are higher level ones here that we have to account for. So what I recommend is, do they have at least a bachelor's degree? So this will be a dummy variable. 13, 14, 15, 16 will all become 1. Everything else will be a 0. Okay, so let's go ahead and do that. Do they have at least a bachelor's degree? And we're going to call this one bachelor's. So 13 through 16 are going to become, label this one college grad, or have at least a bachelor's degree. Old and new values. We'll do a range, 13 through 16 become 1. And we deal with the system missings and the user missings. Then all other values become 0. Okay? Okay. Now we can do our cross tab to see how well this worked out. Everything is slow when I'm recording. So college grad, we're going to put that in the columns because it's only got 2 values. It's going to be much easier than if we had put it in rows. Okay, now hey, take a look. The only people who are 1s here are people who have a bachelor's, master's, professional, or doctorate. Everyone else is a 0. Okay, so we'll go in, do as we did before, get rid of those decimals, relabel this. No BABS, 1, BABS. Okay, so that's all good. Now, let's say you think that people feel differently about John Roberts if they are educated. Right? You could go in and do a dummy variable or a bar graph, right? You could also say, okay, let's see if their favorability towards Obamacare matters, but only if they're educated. Right? That's what we call an interactive relationship. We'll talk about that later, but there's an interesting way to show that here. Okay, so let's say we have our John Roberts statistic going over here. We have our college grad defining our lines. And then we have OCare on our category axis. Now what we'll see here is we get 2 lines, right? We see a really sharp decline. People who favored Obamacare, if they had a college degree, really sharp decline. More gradual decline from opposed to favoring Obamacare if they don't have a college degree. Okay, so again, we might go in, we might change this fill, apply. You might change the colors of each of those lines. That's fine too, right? If you wanted to change those colors, you could. We would adjust that, get rid of this weight thing here, okay, because that's not super useful for us, okay? But once we do all that, then it's going to look nice and pretty. Okay, so we have what we need here to run our regression. So we go to regression, linear. We find our Roberts feeling thermometer. That's our dependent variable. And then we have our list of abortion dummy. You can hold down command or control depending on what machine you're using, right? We can move those over. College grad, abortion dummy, the gun access question, the one that we created. We've got the interest question, the O-care question, party ID, people of color, and I think that's it. Okay, you might include other things here, but that's fine. Then we click OK. And we're going to get some regression results here. Okay, so a couple of things to note here. Number one, what's our N? Well, our N is right here. It's 3119. Okay, so our N is 3119. Don't worry about anything else in this table. If you want the N, this is where you go. This is where you get your R squared up here under model summary. Everything else is down here. Now, ignore the standardized coefficients. Completely ignore that. All right, I'll talk a little bit about that in one of the other videos, but basically useless. Sig is your p-value. So here you can see if any of these are less than 0.05, they are traditionally meeting that level of significance. So are they pro-choice? Hey, that's significant. So people who are pro-choice, on average, rate John Roberts, all else equal, 4 points lower than those who are not pro-choice. Okay. We see also that, is this an important issue? For each unit increase, and that one I think had 5 values it could take, they increase if the more important it is, the more they favor John Roberts. Okay, and you can interpret that by saying for every 1 unit increase in that scale, 1 to 5, there's a 0.68 roughly increase in that feeling thermometer for John Roberts. So over the full life of it, it's still under 5 points change. How meaningful is that when the scale is 0 to 100? Not super meaningful. Okay, party ID. Right? About 1.25 points. That's 7 values it can take. So over an increase 6 times, you're increasing almost 10 points the more Republican they are, ranging from extremely Democratic or strong Democrat to strong Republican. We see here that favoring Obamacare doesn't matter. Their interest in politics, it might matter, right? If you think that people who are more interested in politics like him more, you have a directional hypothesis. So a P of 0.1 or less could be significant. Okay. Do they have a bachelor's degree? Doesn't matter. Okay, so we don't interpret those. So what do you report in your table? Well, you would report, right, the beta for each of these. Or sorry, it's called beta over here. Don't worry about that. B is here. That's what we interpret. That's our unstandardized coefficients. In parentheses just below that, you would report the standard error. Okay. And then you would report the N, which is 3119, and the R squared, which is 0.045. And of course, you could also do a bivariate, right? So if we went in and we went to regression and we got rid of everything except for, let's say, party ID. We just ran a bivariate regression with party ID, right? We'll see there 1.5, significant. But look, in the full model, it's 1.2 and significant. So that change is because we've excluded important variables in this one. So that estimate is biased, suffers from what we call omitted variable bias. Okay, so that's it. That's what you got to do. That's what you'll report in your paper. Again, make sure you're not just copying and pasting SPSS output. You will fail. All right. As for how to move things over into your paper, when it comes to figures, all right, say you want to put this in your paper. Well, you right-click it, export. You want to export it as graphics only. Find a way to export it, email it to yourself, whatever, and then just insert that image into your paper. Okay? Don't export it as a doc. Don't export it as anything else. As for these tables, just take the information you need and put it into those tables. that I linked, those templates that I linked for you. Okay? So if you have any questions, shoot me an email. Otherwise, hopefully this helps. All right? I will see you all in the next set of videos.